What are your TV, that sleek, modern portal to entertainment and information, your fridge, keeping your food fresh and your drinks cool, and those awesome light-up sneakers have in common? Electricity, the unsung hero of the modern age. It's the energy that powers almost everything in our lives, from the smallest gadgets to the largest machines. Without electricity, there'd be no video games to conquer virtual worlds, no cold drinks to quench your thirst on a hot day, and no glowing lights to brighten up the night. But where does it all come from? What's the source of this incredible power? It all starts with atoms, those fundamental particles, the tiny building blocks of everything we see and touch. Inside atoms are electrons, buzzing around like tiny bees. When electrons move from one atom to another, jumping and flowing, they create an electric current, a flow of energy. Think of it like a river, a powerful force of nature, but instead of water, it's a stream of electrons flowing to get things done, powering our world. Plug in a device and you're giving those electrons a path to deliver energy, a highway for them to travel, turning it into light, illuminating our homes and streets. Heat, keeping us warm on chilly nights, or sound, filling our lives with music and voices. Electricity powers our homes, making them comfortable and convenient. Hospitals, keeping life-saving equipment running. Schools, powering the tools for learning, and even our toothbrushes helping us start the day with a smile. It's the invisible force that keeps our world running, a silent partner in our daily lives. Understanding electricity is the first step, a crucial foundation to understanding the science behind our modern lives, the technology that shapes our future. It's truly electrifying, a force that continues to amaze and inspire. How do we harness and control the incredible power of electricity? It's a force that can light up cities and power our homes, but how do we manage it safely and effectively? With circuits, these intricate networks are the key to directing and utilizing electrical energy. A circuit is essentially a closed loop. Think of it as a racetrack, but for electrons. It provides a continuous path for them to flow. If the loop is complete and unbroken, electricity flows freely, powering whatever device is connected. But if there's a break, even a small one, the flow of electricity stops immediately. The circuit is disrupted. Consider a simple toy car. When you flip a switch on a toy car, you complete the circuit. Electrons flow from the battery, travel through the motor, causing it to spin, and then return back to the battery, creating a continuous cycle. The same fundamental idea powers everything from simple flashlights to the most complex supercomputers. The scale changes, but the principle remains the same. A light bulb only works when you screw it securely into its socket, and then flip the switch on the wall, creating a complete and uninterrupted path for electrons to flow through the filament, causing it to heat up and glow brightly. Circuits are carefully designed to direct electricity precisely where it's needed within a device or system. Without a complete circuit, electricity has nowhere to go, no path to follow, and therefore nothing to do. It's like a road leading to nowhere. Circuits are the fundamental systems that make virtually all of our modern technology function and come to life. That's the magic of science in action, all thanks to the power and precision of electrical circuits. Every circuit, no matter how complex it may seem, has four main parts that are essential for its operation. These parts work in harmony to allow the flow of electricity and enable devices to function. These components are carefully selected and connected, working together in a coordinated manner to achieve a specific purpose. First, we need the power source. This could be something simple like a battery providing a direct current, or it could be a wall outlet delivering alternating current from the power grid. The power source pushes electrons to start moving, creating the electrical current. Next, wires act as roads for electrons, guiding them along a defined path. These wires are usually made of copper, a highly conductive material. They're covered in plastic for safety, preventing shocks and short circuits. The load is the part that uses electricity to do work. It's where the magic happens. This could be something like a light bulb, producing light, or a motor, generating motion, or even a buzzer, creating sound. The load transforms electrical energy, converting it into another form of energy. This could be into light, illuminating our surroundings, or into motion, powering machines and devices, or into sound, allowing us to communicate and enjoy music. Finally, the switch controls the flow of electricity. It's the gatekeeper. Flip it on to close the circuit and let electrons move freely, powering the load. Flip it off to open the circuit and stop them, cutting off the power. The switch gives us control over when things work, providing convenience and safety. Together, these parts, when connected correctly, make up every simple circuit, from flashlights to appliances, power source, wires, load, and switch. Remember these four key components. That's the team that makes electricity work for us. Understanding these basics helps you see how all your gadgets work, from smartphones to refrigerators. It's the foundation of electronics, the building block for more complex systems. A closed circuit is a complete loop, a continuous pathway. Switch on, electrons flow freely and the device works perfectly. An open circuit is a broken path, an incomplete connection. Switch off, electrons stop their movement, and the device doesn't work at all. Flipping a switch instantly changes the circuit state, from working to not working. Because electricity is powerful, safety is absolutely key. Never put anything but plugs and outlets and keep devices far away from water. If you see a damaged cord, don't touch it. Tell an adult immediately. These rules keep us safe while using electricity. Knowing about circuits helps you troubleshoot problems and build cool projects. This knowledge could lead to future careers in science and technology. Remember, science is everywhere, just follow the circuit.